Hello guys, how are you today? So today I'll be explaining the remainder of the paper. Okay, so that means from question 15 we were on. So where's question 15? So it's over here. So a glider moves from rest V. From rest V means what? V initial is equal to 0 at a constant acceleration. Anytime you see constant acceleration, you think of UARM of 3 meters per second squared. This is our acceleration along a straight horizontal direction. They told us if the displacement of the glider is 15 kilometers per hour, okay, the time elapsed since the beginning. So they gave us what? The displacement. Okay, I don't know, this doesn't make sense. How can the displacement be in kilometers per hour? I think it's then 15 kilometers. I think this is for sure a mistake because displacement is not kilometers per hour. So let's say 15 kilometers. 15 kilometers is 15,000 meters. Okay? They want to find what the time elapsed since the beginning of the motion. So very simply, we'll have to apply the equation of displacement. Delta x is equal to 1 over 2 times acceleration times time plus v initial times the time plus x initial. Right? X initial is 0 because it's from rest, so let's assume it's 0. So let's just substitute. So the displacement is 15,000 meters is equal to 1 over 2 times acceleration times what? Times the time plus velocity initial, which is 0, times the time plus x initial, which is 0. And the acceleration was what? Acceleration was 3 meters per second squared. So it's gonna be what? It's gonna be 15,000 is equal to 1 over 2 times 3 times the time squared. Okay? So move these to the other side. Time squared is equal to what? Is equal to 15,000 divided by 3 over 2. So divided by, you will get an answer of what? You will get an answer of 10,000. So 10,000 is equal to what? Is equal to t squared. So to find the value of t, you're going to do radical for both sides. So radical answer is 100, so time is equal to 100 seconds. Okay, so again, we used what? We used the displacement is equal to 1 over 2 times acceleration times time squared plus velocity initial times time plus x initial. We substituted all the values given. Of course, this is not kilometers per hour. It's supposed to be kilometers, let's say. And then you will find the time elapsed since the beginning of the motion. We'll move on to question number 16. What does it say in question number 16? Oops, my apologies. In question number 16, it says a car travels for 5 hours. So this is what? This is the time. With a constant speed. So constant speed means URM of 50 kilometers per hour. This is V initial. To the right in the positive direction of the x-axis. And then 2 hours, this is the other time, so time 2, let's say this is time 1, time 2, with a constant speed. So again, URM of what? Of, if I'm not mistaken, 85. So this is what? The second velocity. So 85 kilometers per hour in the same direction. So they want to find what? They want to find the average velocity for the entire journey. They want the magnitude of the average velocity, and then they want the direction. So for sure, you know that it's moving to the right in the positive direction. That means the direction is going to stay in the right because it did not change direction. It just stayed moving in the same direction. So it's going to be the right. Now, how do we find the average velocity? Very simply, what is average velocity? Average velocity is equal to the total displacement over what? Over the time. So what we're going to do is we're going to find the total distance moved or the total displacement by taking what? By taking 50 kilometers per hour and adding it... Sorry, not adding. By taking 50 kilometers per hour, which is velocity initial, and multiplying it by what? Multiplying it by the time, which is 5 hours. Okay, so 50 kilometers per hour times 5 hours, plus what? Plus the second velocity, which was 85 kilometers per hour, times what? Times 2 hours. So, you will add these two together and you will find what? And you will find the total displacement moved. So 50 times 5 plus 85 times 2, that will give us a total displacement of 420 kilometers. Okay, so why did I do this? Why did I use this formula? Because I have velocity, I have time, I need to find the displacement. We know displacement is equal to velocity times time. So you have two different velocities and two different times. You will multiply each one with its corresponding time. So each velocity with its corresponding time. You will add them together to get the total displacement, which is 420 kilometers over the total time, which is what? Which is 5 hours plus 2 hours. So 5 plus 2 hours is 7 hours. So it's going to be 420 divided by 7 hours. So you're going to get what? An average velocity of 60 kilometers per hour, and its direction is to the right. We'll move on to term 3, week 6, physics CA. So question number 1, average velocity at 1 second, 3 seconds. There's not enough information to answer this. But how do you find the average velocity at 1 second, 3 seconds? You will choose the 2 points, like the point at 1 second, the point at 3 seconds, and you will join the lines. You will join the points to make what? To make a secant. Okay, then you find the slope of the secant. Then the slope of the secant is what? Is the average velocity. Okay, here they didn't provide with a graph, so definitely for sure, I don't know how to do it. A body speeding up in the positive sense. Okay, remember, speeding up is positive. In the positive sense, positive. So plus times plus, it's gonna be what? Plus. If it's plus, then it is what? It is accelerating, for sure. But in all cases, speeding up is what? Speeding up is accelerating, okay? Now, if it's speeding up in the positive sense, then the acceleration is going to be what? It's going to be positive. So, by slowing down, as soon as you see slowing down, you will know that it is what? It is deceleration, right? Because it's slowing down. But look, slowing down is negative times what? Negative sense, because it's slowing down in the negative sense, right? That means the acceleration is going to be what? It's going to be positive. Because minus times minus is what? It is plus. So that means it is decelerating because it's slowing down, but it has a positive acceleration. Okay, so speeding up means it's accelerating, but in the positive sense. So it's all about the keywords, okay? We'll move on to question number 3. We have time equals 0 seconds, that means the initial time. Velocity of the particle begins to increase uniformly. If the velocity is increasing uniformly, this means what? This means that the acceleration is what? Is constant. Because if it's increasing uniformly, then that means for sure maybe the acceleration is constant. They said from 10 meters per second, so this is V initial, 26 meters per second, V final, and then 8 seconds, this is the time. Average acceleration in time. So they want to find the average acceleration in the time 0 to 8 seconds. Okay, so honestly, I'm just going to give you a trick. Because the acceleration is constant, that means the average acceleration in this time is going to be the same as the instantaneous acceleration at this time, right? So very simply, a very easy way to find the acceleration would be what? Would be to do V final is equal to V initial plus acceleration times time. So let's substitute. V final is 26. 26 is equal to 10 plus acceleration times 8. Move this there. 16 is equal to acceleration times 8 divided by 8 both sides. Acceleration is equal to 2 meters per second squared. So this is 2 meters per second squared. And because it's an acceleration being constant, that means at 4 seconds, it's also going to be what? It's going to be 2 meters per second squared. We move on to question number 4. What does it say in question number 4? Change in velocity divided by time taken for that change. So the change in velocity, delta. So delta V over the time taken over delta T. This is for sure what? This is for sure the average acceleration. Okay. So for sure this is going to be what? This is going to be the average acceleration. Right? Now, the change in velocity over very small interval of time. So here it's what? The change in velocity but over a small interval of time. So when the interval of time is really small, okay, then we will say what? It is the instantaneous velocity. Okay. Let us move on to question number 5. It said, it gave us what? It gave us 4 graphs. I think you have to match each graph to what they told us. So they told us athlete runs with a constant velocity due east, okay, then stops at a certain distance. So look, let's think about it. We are given what? We're given a distance time graph. So in the distance time graph, the velocity is going to be what? It's going to be the slope. So if it has a constant velocity, then it will have a constant slope. Then it stops at a certain distance, so it will stop at a certain position. So it will have a constant velocity, then it will stop at a certain position. This is for sure our 2. Athlete has zero velocity. When do you have zero velocity in the distance time graph? It is when you have a flat line or a horizontal line, so it's our 1. Then athlete runs with a constant velocity due west. So if he's running with a constant velocity, then he has a slope, and the slope is gonna be what? It's gonna be a straight line. So which one is a straight line? It's for sure our 4. And finally, athlete runs with speed varying. Okay, because the speed is varying, it's not gonna be a straight line. Okay, because it's not gonna be a straight line, which one we will choose? We will choose our 3. Very simply, that's 5. We'll move on to 6. What does it say in 6? It says the distance time graph, I think. They want the magnitude of the toy car velocity at a specific time. To find the velocity at a specific time, which in this case is what? Is 1.6, right? 1.6 seconds. Very simply, you need to draw the tangent at this point, which is the line itself, because it's a straight line, okay? And then you need to find the slope of the tangent, or the slope of the line. So, very simply, just take any 2 points. For example, this point over here, which is what? Which is 0.3. And this point over here, which is what? Which is 2.49. So find the slope. How do you find the slope? Very simply, it's y minus y over x minus x. So 9 minus 3 over 2.4 minus 0. And you will get an answer of what? Of 2.5 meters per second. A car initially moving at 10 meters per second, this is V initial, accelerates reaching a speed of 25 meters per second, so this is V final, in 1.2 seconds. This is the time. They want the acceleration of the car. Very simply, it is what? It is V final minus V initial over time. So V final is 25 minus V initial, which is 10, over the time, which is 1.2. So it's going to be 12.5 meters per second squared. Okay, we move on to question number 8. A car moving at speed of 25 meters per second, this is V initial, in the positive direction decelerates, important, decelerates to a stop in 5 seconds. To stop, that means V final is equal to 0 in 5 seconds. This is the time. They want what? The average acceleration over the 5 seconds. So what's the average acceleration? It's the change in velocity over the change in time. So what's the change in velocity? It's 0 minus 25 over the time, which is 5. This is minus, by the way. So minus 25 over 5, you will get an answer of minus 5 meters per second squared. Now you move on to question number 9. What does it say? It says, which of the following describes the motion of the cyclist? So this is what? I think this is a distance time graph. So because of this distance time graph, so as you can see in the distance time graph, we have what? A straight line. This straight line is what? It is the velocity. It is the slope. The velocity is the slope. So it has what? A velocity that remains constant. Why? Because it's a straight line. Because if it's a straight line, then the velocity is constant. So you will choose this one. The velocity of the cyclist remains constant. Now, question number 10. This is a position time graph. What does the slope of the graph represent? It represents the velocity. Why? Because it's a position time graph. Now the value of motion of the particle is expressed as x is equal to kVt. What is the value of k? Okay, so how I would like to do this is I would like to select a random table over here. For example, let's say this table over here. I have what? I have the distance and I have the time. So I'm going to take the distance divided by the time to get what? To get the velocity. So 3 over 150, it is what? It is 0.02. However, they told us that the velocity is 0.2. So what's the value of k? The value of k is going to be what? It's going to be 1 over 10. Why is that? Because we found what? We found that the distance over the time is 0.02. Whereas the velocity they gave us is what? Is 0.2. So if we were to do the equation, what's the equation? X is equal to kVt, right? So x is 3 is equal to the constant times the velocity, which is 0.2, times the time, which is 150. So 3 is equal to what? It is equal to 0.2 times 150, which is 30, times k. So move this to the other side. K is equal to 3 over 30, which is what? Which is 1 over 10. If you want to put it in simplest form, it will be 0.1. We'll move on to the next part. Term 3, week 5, physics CA. So they told us AB is what? Is 2.5 kilometers. BC is 3.7 kilometers and CD is 5.8 kilometers. So they said what? They said A to B in 2 minutes, B to C in 3 minutes, C to D in 5 minutes, and then the average speed S of velocity AB, velocity BC, and velocity CD, they want us to compare it. So how do you find the average speed or the average velocity? Very simply, it is what? Average speed is distance over time, but average velocity is the displacement over the time. Okay, so they want to find what? They want to find the average speed of each. So let's start with the average velocity of AB. From A to B, what is the distance moved? It's 2.5 kilometers, which is 2,500 meters, divided by the time. The time from A to B is 2 minutes, so 2 minutes is 120 seconds, so it's 2,500 divided by 120. It will be what? It will be approximately 20.83 meters per second. Okay, for VBC, okay, what's the distance traveled VBC? It is 3.7 kilometers, so 3,700 kilometers divided by the time, so 3 minutes, which is what? Which is 3 times 60, which is, I forgot how to do math, 180, okay? So 3,700 divided by 180, it will give you what? It will give you 20.5 or 20.56 meters per second. Now for the last and final one, which is the velocity of CD, it is what? The distance, which is 5,800 kilometers divided by the time, which is 5 minutes. So that's 300 seconds. So it's going to be what? 5,800 divided by 300. It's going to be 19.33 meters per second. So for sure, which has the highest velocity? It's velocity of AB. Then comes velocity of BC, and then comes velocity of CD. We move on to question number 2. Particle moves along x-axis from point A, minus 5 meters, to B, 10 meters, to C, 2 meters. They want to find the net displacement. Very simply, as we said, to find the net displacement, it's x final minus x initial. So what's x final? X final in this case is 2 meters, minus x initial, which is minus 5. So 2 minus 5, that's going to be 7 meters. We'll move on to question number 3. It says, toy car is confined to move along a straight line. It moves how much? It moves 12 meters. So this is delta x, or the displacement, in the positive direction. Then turns around and moves 8 more meters. So, okay, let's say this is, first it moves 12 meters, then it moves 8 meters in the opposite direction. They want to find what? The distance traveled by the car. So let's draw it together. So, let's say it was at 0 initially. So from 0, it moved what? It moved 12 meters. Then after moving 12 meters, it moves back another 8 meters. So it moves 8 meters back. So let me just extend the line because this is too small for 8 meters. So it moves 8 meters back. So first it moves 12 meters in the positive direction and then 8 meters in the opposite direction. That means it is at which place? It is at the place of 4 meters. Now, the distance traveled by the car. There's many ways of finding the distance. You can do it logically in saying, okay, he traveled 12 meters plus 8 meters. What's 12 plus 8? That is 20 meters. This is the distance traveled. Or another way you could do is by the absolute value of the net displacement. So how do you do that? First, you start with the first phase. The first phase, you will do x final minus x initial, so 12 minus 0 in absolute value, that's 12. Plus, in the second phase, it is what? It is x final 4 minus x initial 12 in absolute value, that is 8. So 12 plus 8, this will give us 20 meters, same exact thing. Whereas the displacement of the car is what? Is x final minus x initial, so 4 minus 0, so the displacement is going to be what? It's going to be 4 meters. Okay, we'll move on to question number 4. It says, light spot moving horizontally along the x-axis from point x minus 3 to x2. It then moves horizontally in the opposite direction to x3 minus 1 meters. What's the total displacement of the light spot? So look, they do it for us. First, it started at what? From x minus 3, it went all the way to what? To x is equal to 2. After this, what happened? It moves in the opposite direction to minus 1. So the total displacement of the light spot is what? It is x final, which is what? Minus 1, minus x initial, which is minus 3. So minus 1 minus minus 3, that's going to be 2 meters. So the total displacement of the light spot is 2 meters. Whereas the total length of the path, remember, you could do it logically. You can say first he moved from minus 3 till 2. What's the distance from minus 3 till 2? That is 5, if I'm not mistaken. And then from 2 till minus 1, that is also 3. So 5 plus 3, that's going to be 8. You could do it like this, or you can take the absolute value of the net displacement of each phase. So the first phase, what's x final? X final is 2 minus x initial. So minus 3. It will give you what? Absolute value of 5, which is 5. Then for the second phase, what's x final? It is minus 1 minus x initial, which is 2. Put it in absolute value. So absolute value of minus 3, that is 3. Add them together and you will get what? You will get 8 meters. Question number 5. Displacement. Okay. Displacement is what? First of all, it is a vector quantity, meaning it has a definite direction and magnitude. So displacement is a vector quantity. It has a definite direction and magnitude, while the length of a path is what? It is a scalar quantity. That means it does not have any direction. It only has a magnitude. This one I'm not sure. I just answered it from what I think is correct. So please do double check with your teachers. Question number 6. Which row is true? So average velocity is vector, average speed is scalar. This is very correct. Why? Because average velocity is displacement over time, and we know that displacement is vector. So if displacement is vector, then velocity is vector. And average speed is distance over time. We know distance is scalar, so if distance is scalar, then speed is scalar. Row 2, average speed is vector, no. So these are all wrong, so row 1 is the only true one. We'll move on to question number 7. Particle moves along the x-axis, okay? Right? From point A, this is what the first position, so x initial, or no, from point A, x minus 3 meters, straight to point B, x equals 9.25 meters, and then to point C, x equals 4 meters. The journey from A to C takes what? 3.5 seconds. So how do you find the average speed? Average speed is very simply what? It is the distance over the time. So let us find the distance traveled, okay? To find the distance traveled, we'll need to draw what happened. First, it starts at what? Let's say this is 0 over here. Okay? It starts at minus 3. So from minus 3, it moves from A all the way to B, which is what? Which is 9.25. And then from B, it decides to move back. It decides to move back all the way to X is 4 meters. So the distance traveled is what? The distance traveled over the time. It is what? You could take the absolute value of each stage. So the first stage is what? X final, which is 9.25, minus x initial, minus 3, is equal to what? Is equal to the absolute value of 9.25 minus 3 of 12.25, or it's very simply 12.25. For the second phase, which is from B to C, it is what? It is absolute value of 4 minus 9.25. So it's absolute value of what? It is then the absolute value of minus 5.25, so it's 5.25. Add them together, so it's 12.25 plus 5.25. You will get that the total distance traveled was 17.5 meters. Over the total time is what? 3.5 seconds. So 17.5 over 3.5 will give us an answer of what? Of 5 meters per second. Oh, there's still a lot to go through. So let's move on to question number 8. Person follows path ABCD. AB is 3 meters, BC is 7 meters, ABCD is covered in 5 seconds. So they want the average speed. Here, look. Average speed of the person. So average speed of the person is what? Is distance over time. So we'll need to find the traveled distance, okay? The traveled distance from A to B to C to D. So A, B, C, D. Right? This is what is the travel distance. So it's 3 meters plus 7 meters plus 3 meters, which is what? Which is 13 meters, divided by the total time, which is what? Which is 5 seconds. So it's going to be what? It's going to be 7.5 meters per second. Or sorry, 6.5, not 7.5, 6.5 meters per second. So the average speed is 6.5 meters per second. Because we're talking about speed, it's along the path. It has no direction. Whereas the average velocity, this is very important. Average velocity is the displacement over time. So how do you find displacement? You will take the final position, which is D, and the initial position, which is A. You will draw a straight line, and you will find the distance. So from A to D, what's the distance? It is 7 meters, because it's a rectangle, right? So it's 7 over the time, which is 5. So it's going to be what? It's going to be By the way, I did this wrong. It's not 6.5, it's 2.6 meters per second, my bad. This is 2.6 meters per second. Whereas 7/5 is what? 7/5 is 1.4 meters per second. So you can see that the average speed and average velocity change. Why? Because one is distance over time and one is displacement over time. And we know that average velocity is a vector quantity, so for sure it's gonna be directed rightwards. Okay. Cyclist travels distance of 22.3 kilometers in 3.7 minutes, stops 5 minutes to rest, then travels another 17.2 kilometers in 31 minutes. They want to find the average speed in kilometers per hour. Very simply, all I will tell you is what? Is you need to find what? The average speed. So average speed, my bad. Average speed is equal to what? Is equal to the distance over the time. So what you're gonna do is you're gonna calculate the total distance moved. Okay, so let's find the total distance traveled. That is what? It is 22.3 plus what? Plus 17.2 kilometers. So 22.3 plus 17.2, that's gonna be what? That's gonna be 39.5 kilometers as the total distance. Now, 39.5 kilometers. We need to find the time. How do you find the time? The total time is 3.7 minutes. Plus 5 minutes, don't forget this, plus 31 minutes. So in total it is what? It is 39.7 minutes. Now, of course, they want it in kilometers per hour, so you have to change the minutes to hours. So you will divide by 60, 39.7 divided by 60. You will get an answer of what? You will get an answer of 0.66, right? So now you have the total distance traveled, the total time taken in hours. So 39.5 kilometers divided by 0.66. You get what? You get 59.85 almost kilometers per hour. This is the average speed. Now 10, I don't have enough information to solve it. I'm gonna stop the video here so I can do the term 3 week 9 physics CA like alone. And you guys get the video early. So bye.